Alright, here we are on the PLL board, and this section mid-screen is the VCO5, usually surrounded by this can, and we're removing the parts. So we got a couple parts so far. I think that's an inductor actually, and a couple electrolytics. I take lots of pictures, I'm taking notes, comparing it to other people's work. And once I get all the parts out, then I'll clean up the goop. There's even something I wanted to point out. Look at all the goop on the inside of this thing. These parts are hard to get out, even though they're unsoldered. Sorry about that. They're hard to get out, and they're really stuck in there. So let's see what happens. Be right back. We're making progress on the old VCO5. You can see a bunch of parts missing. Part of what I'm doing is putting them on something, you know, like 10 times the scale so you can write next to them what they are and stuff. You can see the can is up here. Here's the tuning can here. So everything's in the relative position and its value, in case I bump it. Anyway, it's coming along. And should be another few minutes and have everything out of there. Alright, here we are on the VCO5. Everything was removed, including the can. And I'll tell you right now, my best friend is this here solder wick. It's super fine. My coarse solder wick was kicking my ass. Alright, so there we go. It needs to be cleaned up. I'm going to do that right now. I'm going to try and take a hot soldering iron across it. I've done this before with different kinds of conformal coating, and it worked really well. So let's see how this goes. Here is, I don't know, it's a sheet of notebook paper, and it sure is handy having it spread out like that. Everything's labeled, part number, designator, and value. As long as I don't breathe on it, it's fine. Alright, be right back. Here we are, VCO5, clean, and the silk screen is in pretty good shape. I don't know if you can see the diode. Where is my finger? Diode's at the tip of my finger there. You see that the silk screen, the diode symbol is almost gone. What I've been using is I used isopropyl alcohol, and then after that acetone. The primary roughing tools, if you will, are screwdriver and needle nose. And you can see how acetone takes off the goop really well. In fact, it softens it, so it's easier to get off with a screwdriver. But I would do as little scraping as possible, and the reason being, you can plug all the holes. You can plug all these holes with goop, and then you got to take wire of some kind or whatever you got and push the crap out of the holes. So I did try the soldering iron across it, and it really filled in the holes. So the soldering iron wasn't the way to go. But man, look at that, clean as a whistle. So the next step is to, I don't know, I could do a combination of things. I need to clean the goop off the parts. Some are really clean and some are not. So what I need to do is clean them up and reinstall them. So I think what I might do is take the cleanest ones and install them first. And then as I get to each of them, clean them up, just scrape them with a X-Acto knife. I should have put that in that shot as well. There's my X-Acto knife. It cleans up pretty good. It comes off alright. I did have one failure. Where is it? You see that capacitor right there? It's all broken into little bitty pieces. So that made me wonder, was that capacitor bad? Was it damaged from, you know, when I reflowed? What the hell? I don't know the answer. So I wrote it down. What is it, about I don't know what it is. R152. It's just a few puff. In fact, I think I have to go look it up on the schematic. R152. So that's the only damaged part I have. Everything else came out really easy. The solder wick really made quick work of that. Anyway, it's sterile, and I mean sterile. The only thing you have to be careful of is use your alcohol first, and then use the acetone for the finish, because acetone does slowly start taking off the solder mask. No, solder mask, the pad printing. Anyway, the white stuff on this board, it's actually air dry single stage epoxy is what they use in industry. So if it was two part epoxy, it would never come off. Anyway, that's pretty darn good. I'm happy. I'll start putting stuff together. It takes a while. Sitting at this bench hunched over and stuff is pretty hard on the old body, so I'll get to it as soon as I can. See you, bye. Here we are with the PLL board reinstalled, and it's looking pretty good. Now there's a little note I wanted to make, and I forgot to do it earlier. Let's see if I can show you. I'll zoom in as close as I can. Alright, you see the... Man, I don't know if we're going to be able to do this. You see the tuning can, and above it you see that green mylar capacitor, and just to the right of that cap you see a resistor. But the silk screen has a big circle for an electrolytic cap. So there's a resistor in the place of an electrolytic cap. I saw another guy's video and I noticed the same thing. So I think that's normal. So when any of you guys want to start working on this, just make a note of that. There's a resistor there from the factory. Okay. Hopefully you can see it in this video. I'm shooting this all by hand. What I did is I took, and as I identified the parts and put them on my enlarged map here, I wrote down black, orange, silver, brown. Now I didn't necessarily read the resistor in the right direction. It could be brown, silver, orange, black, although silver's not a standard color, it's a tolerance. So anyway, you might have to look at your own to find out what the value is, just so you can put it in your records. But that's basically what I saw. It may not be silver, it might be white. But I didn't really care. I just wanted to, it's different from all the other resistors. So, but see, I even wrote down it's a circle, and then it had a bigger circle around one of the holes, which is for the, I don't remember the negative. I don't remember. I have to look back, and it's not that important right this second. It's just something I wanted to point out. So anyway, the old girl's installed. Let's find out if we're doing okay. Powered up. Boom. Okay, so the display works, and the important difference after all of this work, even though the video at this point's barely even 7 minutes old, you see, it doesn't flake out and give me dots when I move it. And that was a big deal before. You move the tap on it and stuff, and it was going in and out of lock. So it's working fine. Everything came out the way it was supposed to. Now, there's 2 steps you have to perform once you reinstall the PLL board. The first thing you have to do is a factory reset. When you pull a board out like that, you have to. It's just the way this thing's made. You push A equals B, and then hit the power at the same time, and it'll come up with 14.0000 megahertz, and it'll be reset. Because if you just turn it on, the display will be scrambled, and it won't necessarily be a hardware problem. So you always reset it. If it shows up at 14 and then goes down to dots, then you have to tune the can. This is VCO5. you have to tune that can to 5 volts tied to, you put your voltmeter across this lead right here. That's actually test point 11, the end of the inductor. And then ground, pick a ground anywhere. I usually just clip it to the can. And you adjust that thing, super sensitive, man. You barely move it and it'll jump a volt. But that has to be done. And then once this is set properly, and also VCO1, which isn't very well lit, but you see these cans right here? When those are all set, you won't get dots anymore. So it turns out, let me go backwards a step. I found in this thing there was several ways to get the dots on the display. The first way for my unit was the circuit boards. Back here there's 2 of them. You can't really see the second one back here, but there's 2 of them here, and I had to reflow all the solder on both of them. And that fixed that problem, because all I had to do was grab onto the metal frame here that they're bolted to and give it just the most gentle twist and I'd get dots. So once I reflowed that, it brought that down a lot. It brought that down a whole lot. Then, see, so that's one source. The second source is when you're messing with one of these TS-440s that you don't know anything about because it's new to you. The VCO5 should be just about the first thing you check, because if it's off, you'll have dots. So set it to 5 volts, and that's, I know that's ahead of time more than you want when you're troubleshooting something. But if it's not at 5 volts, you will have dots all the time, and you may have to reset this a couple times to 5 volts as you troubleshoot. You clean the goop out, the tuning changes. You resolder the board, the tuning changes. So just remember, factory reset, set the VCO5 can to 5 volts. Those 2 steps are huge in troubleshooting when it's more than one item that's causing the dots. And on mine it was, I lost track. I don't even know how many items I had. I had goop, I had bad solder, and I had bad solder on these. So it's like 1, 2, 3 issues I can already guarantee you were the problem. But now it's perfect. I can move the display, tilt it, and it just all stopped. What made me suspicious was, as much as I wiggled the wires, I never found anything consistent that would trigger the display back and forth. It just, I couldn't find it. So I said, okay, bad solder isn't just about mechanical connections. Sometimes it changes the resonance or the frequency of a circuit. And so that's why I said, all right, I need to pull this board out, reflow the whole stupid thing, and it was worth it, because now it'll at least on its solder, it'll last forever. You know, maybe someday it'll need caps, but I'm not going to worry about that right now. There's too much broken to worry. So, okay, the display is stable. That's cool. That's really cool. The next issues I've got, it'll take a whole nother video. So the next issues are why I took the antenna tuner out. There's no power. There's no RF. You can use the send button. You can use the mic. There's no RF output. So I must have screwed something up. There's a lot of bad solder in these things, and sometimes you think it's your own fault, and it turns out it's just the bad solder is like the ghost in the machine. It'll flake on you, and then it'll not flake on you, and it's really bad. That's why I put in so much time fixing bad solder. Almost every piece of consumer electronics I've ever worked on has bad solder, especially as it ages. It's marginal to start with, and it ages poorly. So anyway, right now I got no transmit at all, and guess what? I also have no receive. Now I don't know what happened to the receive, because I remember last year when I worked on this I had good receive. So I have no receive, and I have no transmit, and they happened at separate times. The no transmit problem occurred once I put the board in and I tuned the VCO. I transmitted and there was power output. There was, 50 or 100 watts. And then everything just stopped and the thing went blank. And I powered it down and put it back on, and it works. But the display works, but the thing does not transmit anymore. So anyway, okay, who knows what it is? Did I screw it up? Who knows? There's no way to know. A year ago, I blamed myself for causing the display failure, and it wasn't me. It turns out it wasn't me at all, and I sure beat myself up for that. So do be careful when you're working on these things. They're super complicated. Just understand that they can be really flaky when they get this old. And it's the soldering. I've done it with televisions and CB radios and 10-meter radios, and they all have the same problem. It's the solder. It just kills them. So anyway, it's running. I'm thrilled about that. The display is stable. I even stuck all the knobs back on in celebration. It's starting to look like a radio again. I don't know. What do I want to pick? Do I want to go after the transmit or do I want to go after the receive? So I'll decide and make another video another day. Or in my case, probably another week. Alright. Thanks. Sorry if I bored you guys to death, but I think this is important. See you, bye.